It is May 18th of 2024. It's Nye's 4th birthday, and we want to compare these two energy efficient options. Now, Mom is here and she got us this new wave. It is a induction cooker, and so it uses less electricity than resistance heating, but it requires magnetic pots. Here I have 4 cups of water in here, and I have 4 cups of water in a regular pot on top of a home biogas stove, and we're going to see which one boils 4 cups faster. So I'm going to start by plugging in the induction heater, and it's set to 375, and here's the biogas. So let me turn on the biogas pump, which is on now, and then that is on, and let's see which one goes faster. So let's see when they start boiling. So we're going to just hang out for this, and I want to talk a little bit about, in the modern kitchen, there is the idea now that we should be moving away from gas and moving toward electric. And of course, as solar electric prices drop, that becomes more and more feasible. However, if you invest in a solar electric system, and we're on solar power here, you're going to use a substantial amount of those electrons that you've paid for and that you're waiting for the sun to produce to get water heated up. And if you're using resistance heating, it's going to just totally bankrupt your battery bank, or it's going to totally exhaust your savings. So you definitely don't want to do resistance heating, and that's why Mom got us this induction cooker, which induction is a electromagnetic process where it's not heating something on the plate, it's transferring energy magnetically to the cast iron pot, and then that's transferring that to the water inside. And then here you have biogas, and biogas is of course biomethane that we're producing from food waste. It is totally free after you have built the biodigester. What costs is, of course, the time and labor to load it with the food waste. You need food waste to do it, but you get that every day, and every bucket of food waste produces about an hour to 2 hours of cooking on a stove of this size at that type of flame. So you have these compromises. This is a special stove, the home biogas stove. And the only thing that makes it special is that it has the restriction pin removed, so it is allowing gas that is not under pressure to go through, and there's no venturi opening to draw air in like you'd find on a propane stove. So it's just a piece of pipe. We're using this pipe here that is a plastic tube going into the metal pipe in there, and then the distribution from the flame head. And so it's obviously a very simple system. You can turn any stove into a biogas stove by removing the restriction nozzle and by closing up any holes that are inside that we're letting air in for the propane mix, and it'll work as a biogas stove. Really nice to have though, and what we're seeing now, both of them are heating, but it looks like, and let me see if there's a light here, looks like we're getting more bubbles in this than this. I know it's a little unfair because the surface area is different. This is a thinner pot, this is a wider pot. So obviously to do this scientifically, the pots would be identical. But it's the same volume of water, and we're putting energy into that volume of water and just trying to see who wins. This is beginning to bubble as well, but this has got far more bubbles. We're seeing steam on both of them. And we're beginning to see actual bubbles, boiling bubbles here, quicker than in there. So they're both working pretty well, but look, this one is definitely coming out, and in very few seconds these bubbles are growing. It's going to get bigger. I think this is going to be the winner, but they're both working. So the question is, how much energy are you putting in? Now, this pump is either a 10 or a 20 watt aquarium inline air pump, and we're putting biogas coming in through this plastic hose to the back and then looping it around to here. And this is induction. Now, both of them are safe from a child's perspective, because if you take this pot off, this will shut down. This surface is not hot. An induction heater is not like a resistance heater. There is no heat here. You can see me touching, well, it's hot, but it's not going to fry my fingers off because it's really sending the magnetism into this pot. Actually, if you look now, you'll see they both have formed bubbles, but this one is definitely the winner. It's bubbling far more vigorously, and this one is just beginning to get there. So, and this is at a medium flame. Of course, I can turn this flame higher and I can get a faster bubbling, and now it's really going. Right, so now we have a definitely clear winner. If I open this all the way up, of course that uses more gas. If I turn it down, then I can lower the flame, and I have complete control of it. And so there we go, a winner for sure, while this is still trying to get there. So there you have it. If you want a quick meal and you want to boil spaghetti, you want to make an egg, biogas wins over induction heating, which definitely wins over resistance heating. We don't know about the microwave. We'd have to test this with microwave with 4 cups of water and see. Anyway, now that we have this, we can cook some dinner. Thank you very much for watching. Let's just take a close-up of the beautiful blue flame. That's what we get in biogas, and yes, it is safe to use indoors. So thanks for watching.